So we started this webinar series in March, to kind of cover the overall building blocks of the cloud. The idea is to kind of touch upon each and every item, which which becomes part of the cloud eventually, right? So we started with basics of cloud computing, virtualization, and then today we are going to do containers and orchestration, and then we'll continue further. So this webinar series I try to create to make sure that we can answer the question why or how we can build our own cloud. So basically, if we have all the building blocks, um, then if we understand, then we can build maybe our own cloud as well. So rather than kind of understanding or kind of going to a specific cloud provider, if we can answer how we can build our own cloud, that is where things are going to become more interesting. So with that, let us kind of jump into our today's topic of containers and orchestration basics, the overview of it. So before we kind of jump into the content part, I'll just want to do a quick intro about myself, and then we'll go with the content part of today's session. So as you know, my name is Nipendra, and I'm founder of Cloudhiga. So before starting Cloudhiga, I worked for over a decade in different companies, though primarily with Red Hat. But I have experience as system administration, support engineering, file system, kernel development, and perf engineering. In 2015, I published a book on Docker. So this is a book which I published in 2015, which is maybe one of the first Docker book which was available in the market. So I published this book, and after that, I realized that this is going to change the way we develop and deploy the applications at scale. And that's what I decided to kind of start Cloudwiga in 2015. So it's now been around say around 8 years since we are existence of Cloudwiga. And since then, we have been training different companies, corporates on this technology. And we have built our own training platform to deliver these trainings more effectively. So we have trained in companies like Intuit, Flipkart, and many more. And I also authored the official first Intro to Kubernetes course for the CNCF, taken by more than 200,000 across the globe. And then also, I published further courses for Linux Foundation and CNCF there. I also run the KCD Bangalore. KCD is Kubernetes Community Bangalore event. KCD is across globe, but I'm part of the Bangalore event and one of the CNCF ambassador as well. Yeah. So with that intro, let us jump into today's topic. And if you have any questions which are coming to your mind, please put them on the chat. There's a chat tab you would be seeing. So if you have any questions, meanwhile, while we do the webinar, or if you have any questions in general also, please go ahead and put them on the chat, and I'll be able to take them as we go or after the session. So we'll see how we'll take them. Okay, so now to understand the basics of containers and Kubernetes, that is what we have thought of finishing up. So I'm going to use our platform to deliver this content, and so this is our Cloudiga's website. You can open this link. I I believe you can see that, but I'll put on the chat as well. So if you go to this website, we have some courses and which we're going to use today, and you can also practice along with me, or you can do it later as well. So if you go to learn, you will see courses there, and there we have the first course which you want to use today for container funnel Docker. This has 1 day of free trial, while the Kubernetes 101 course is free. So we're going to use these two courses to kind of look at our content and do the hands-on of whatever time we have. Okay. So I'm just going to jump into the Docker course first, which I have already kind of there, but you can go to the site and sign up right away if you want to. So now this is what we have as a course, what we have for the Docker, and I have triggered the lab already. So once you sign up, once you kind of get into any of the course, what happens is you can actually I'll show you how it looks like. So we have different courses. So for example, if I'm going to any course, now once you go into any course, you'll have some number of hours of lab running. So what I have done is for the Docker course, I have already triggered the lab environment. So you can trigger it as with me. So what will happen is once you have triggered the lab, you will get a lab environment to practice. Like I have got a terminal to work with, which you can also get right away if you want to practice. And there would be an IDE also on which we can write the code and everything as well. So all of these things comes as a part of platform, which we are going to use today to show it some demos to you. Okay, so with that, let's kind of try to jump into the content as we have only 1 hour and cover the basics of containers and Kubernetes. So we'll kind of do a quick thing. Okay, but I still want to kind of give you enough so that you can go back and practice on your own as well. Okay, so now let's start with the containers. What are containers and why we are using them, right? So the containers name has come from the shipping industry, as you may know. So what happens is when you want to ship something across the globe, right? We put something in a standard box. Now this box size is fixed. We have the device or kind of a say the machines to manage it, to pick them up, to put them back, and all that stuff, right? We have machinery for that. So across the globe, everybody knows how to handle this particular box. And that is what the term container has come from. So in the IT world, this particular box, what we see here, it becomes like an image. So an image is nothing but your application, its dependency bound together. So what you're seeing here is a box, which was I kind of referring earlier. This box contains your application, what you want to run, along with the dependency. Now, once we have made an image out of it, what you want to ship, right? What you want to run. Now, this particular image, what we have, can run on different environment, which would become container for us, right? For desktop, dev, QA environment, public cloud, private cloud, wherever you would go, it would run as it is, right? So, the containers are nothing but you package your application with the dependency, make it an image, and that image would run irrespective of the environment you are in the same way. Correct? So that is what over at a very high level what containers are. We'll dig deep further as well into this. Now, why somebody want to use containers? Primarily reason why we adopt anything, because it is going to save time and money for us, right? So when something saves time and money, we adopt it. So similarly, that is very much the reason why a company or individual would choose containers. So so when we use containers, how we are going to save time? Because as you know, the same app is going to work in a similar way, irrespective of the environment you are in. So this makes the dev cycle very straightforward. So earlier used to happen is, for example, developer develops, but when it goes to queue and production, they cannot run it or execute it because of the latest libraries and so on. And that kind of wastes a lot of time and effort for different people. But if we move to containers, it is going to run the same way irrespective of the environment you are in. Hope it makes sense. The second part is going to save money because we are going to package more application the same hardware. So think about if you are able to run 10 VMs on the same hardware. Now, because we are moving to containers, we can run multiple of the VMs on that, correct? So for example, if you could run 10 VMs and deploy one app on each one of them, which means on a same hardware, you're deploying 10 VMs and run 10 applications. But if you go to containers, it can run, let's say 5x of them, 50 of them, kind of a thing, right? So it's going to save money. And that is why companies are adopting the containers there. Hope it makes sense to all of you. Then the next part is when somebody talks about the VMs and containers. So you may hear the term that containers are lightweight VMs, but that is not true at all. It is good for analogy, but not true at all. So for example, if you look at here, we have in the VM thing, right? So what we have our host OS, we have hypervisor, and on this hypervisor, we create our VM and then deploy our applications. So this is how the VM would work. So hypervisor creates these VMs. On top of that, we are going to deploy our applications. Make sense? Now, if you look at here, what is happening here is we have to create VM to deploy each application, but our end goal was to deploy the application. So what if I take this application and run directly on the host system such that this app behaves like an independent entity, which means this app is going to have its own host name, IP address, and so on. Correct? So now, this app behaves like an independent entity. So as you can see here, there are no layers of the VM here. They are directly running on the host system. Correct? So if you look at in the real term, a container is nothing but a program which runs with its own identity, IP address, host name, and so on. And that is why the containers are very lightweight. Okay, hope this makes sense. So VMs and containers are two different things. Okay, so we have few questions on the chat here. One is if our host OS is 16 core CPU, does VMs also get 16 core CPU? So see, depends. When you're creating the VM, you can choose how many CPU you want to give to each VM. So it depends, right? When you're creating the VMs, how many CPU core you want to give. Hope that answered the question. Second was, do we have to have any configuration to give one core or two CPU to a container? Yes, you can do that. Like the way you can give the resources to VMs, you can give to the containers as well. So I'll talk about those things as we continue. Okay. Um, so hope this makes sense. Now, just one point here. Um, when somebody says that we are deploying a container, so for example, if you would have heard about that, I'm deploying the um, container of Ubuntu. Let me actually explain it in one more way here. It's kind of going a bit off second, but that's perfectly fine. Okay, so hope you can see my screen. So when we have any OS, for any OS, we have two things. One is we refer as a user space term, and then we have something called as kernel space. So for any OS, whatever you have, for every OS, you're going to have a user space and the kernel space, right? Now, in the user space, you would have editors. For example, you can open your browser, editor, and so on. Those would be part of your user space. Or think about you are writing a program like in the Python program, you write, let's say, open, and you give your file name and the mode which you want to open it, right? Write mode, for example. Now, this Python program or this editor, what you have, cannot actually go and create a file on the hard disk on its own, correct? So if I have a hard disk here, my program in the user space, which is nothing but a Python program, cannot on its own create a hard disk or a file in the hard disk there. So what happens there is my request from the user space goes to the kernel space, and then from the kernel space, it is going to then create the hard disk or create the file in the hard disk and so on. So every OS has this user in the kernel space there. Okay, hope this makes sense. And the layer which kind of, in the Linux terms, the layer which does this particular work is called as glibc. So glibc, which implements what? If you have guessed it, system calls. So system calls are a way using which my user space program can talk to the kernel. So if I'm going to create a file from a Python program, it would call a system call open and then write and so on to go to the kernel and go and write the respective thing on the hard disk. Correct? Hope this makes sense. Now, if you continue further on this, when somebody says that, okay, so while we are here, so let's talk about Yeah. So let's talk about something like similar. So let's say somebody says that I want to create a container of Ubuntu or a container of Fedora and so on. So for example, our underlying system, what we have, is it of CentOS, which is a Linux variant. Okay. And then I'm creating a container of Ubuntu and a container of, let's say, CentOS again. Okay. Now, when somebody says that I'm going to create a container of Ubuntu, Fedora, or any other Linux variant on my CentOS system, what we typically mean there is I am just deploying the user space of Ubuntu or CentOS and so on. Okay. So let me repeat again. So when somebody says that I'm deploying container of Ubuntu or CentOS and so on, what that typically means that I'm going to deploy only the user space of a given distribution. And all of these containers are going to share the same kernel what we have on the system. So if I go back to the previous diagram which I was discussing here, you can see here, in this case, there is a common kernel. In the case of VM, every app has its own VM and its own kernel. But in terms of containers, all of them are sharing the same kernel of the host system. So what is happening here is all of these containers of Ubuntu, Fedora, or whatever, they are having their own user space. But then for the kernel part, they talk to the same kernel what I have here. That is how the container works. They only have the user space component, and from there they communicate to the kernel what I have there. Hope this is clear to everyone. Now, so this makes very clear that there are going to be a dependency between the container you are running and the underlying kernel or the OS you have there. So answer a question for me. So for example, can I deploy the container of Windows, right? Can I deploy a container of Windows on a Linux system? What we discussed earlier, Ubuntu and CentOS, they only have user space component, but they are going to have this glibc with them. And because of this glibc, they can talk to the same kernel what I have. So there is a compatibility between the container and the OS you have because of this common glibc layer what I have on my system. Correct? This is very important. So the question which I have asked, can I deploy the Windows containers on the CentOS or not? Answer yes or no in the chat, please. Divya says yes. Okay. Dhananjay says no. Okay. So now, if you look at here, what I mentioned earlier, that there has to be a compatibility between the container I'm deploying and the OS what I have. Let me just repeat that part to make it very clear. See, these containers can communicate to the underlying same OS because they are all Linux variant, okay? And because they are all Linux variant, so in all of these user space thing, we're going to have the respective glibc here. And now this glibc is a way to kind of transition me from user to kernel space. And because of this, this particular thing is going to work out because this glibc can talk to the kernel what I have to create the file on the hard disk. But this Windows would not work because the Windows user space does not understand glibc, and that is why it cannot talk to the underlying CentOS. Correct? So there has to be a compatibility between the container you are deploying and the OS or the underlying OS what you have. Hope this makes sense. Now, on a similar line, what you would have also seen that we can deploy. So, for example, if you have a Mac or a Windows machine and you install Docker Desktop, and on that Docker Desktop, you can deploy your Linux containers on that. So, how is that possible? That is possible because when you deploy this the Docker Desktop, what it does is it creates a transparent Linux VM for you, which you are not seeing, like, which is not kind of shown to you. So what happens? I'm talking about in terms of Mac and Windows. When you deploy this Docker for desktop, and you are running the container of Linux here. So we discussed earlier that there has to be a compatibility. So I cannot run the Linux container directly on the Windows machine. So what happens when it deploys Docker for desktop? It creates this thin VM, which we refer as, or not refer, which is like a thin Linux VM, which is transparent VM for you, which is a thin Linux VM. And because of this, our Linux container talk to the Linux kernel only, but this kernel, which is there, which is transparent VM, can talk to the underlying Mac and Windows, and that is how it would work. So just to make it very clear, there has to be a compatibility between the container and the OS you are running there. Clear? Okay, so hope this makes sense. Okay, great. Now let's try to look at some more part here, a bit of history of containerization so that it becomes very clear. Now, the containers are not new. So containers have been there for 25, 30 years almost, right? It's just that consuming them was a bit difficult task. So Docker has just made things very simpler. But if you look at the container technology, like which has been like in bits and pieces, like chroot, bsd jail, soaz zones, they have been there for many years. It's just that consuming them was difficult earlier. Now what Docker did is Docker kind of made things very simple so that things are very streamlined. But container technology is not new. It's not that Docker has come and made everything from the scratch, right? So I'll not go further into this. You can actually go back and watch this video because you'll have access to it. I'll talk about the next part here, which is the building blocks of the containers. So if I talk about in terms of Linux, there are two features. So currently, if you look at on my current system, I don't have Docker installed here. But I have two things which are very basic or very fundamental to create containers. One is the concept of namespaces, and second is the concept of C groups. So what is this? So namespace is a way to isolate resources. So for example, if I go to any one of my, so this is a cd/proc. This /proc contains all the different PIDs what I have on the system here. So for example, if I go to the PID, which is any PID I can pick up, and here I'm going to have a folder called ns. Now this ns folder is going to contain something called as namespaces. So with the namespace, I can isolate resources. So for every program in Linux, I can assign a unique IP address to it if I want. I can assign a unique mount point to it and so on. I can assign every program a separate host name. So all of these things are possible uh, because of the feature of namespace of Linux. Similarly, we have another feature called cgroup, which I'll not touch upon right now because it'll take another time. So cgroup is another feature of the Linux kernel, which is going to help me allocate resources for my application. So again, we have not installed Docker at all, but just try to understand in Linux, we have two features, namespaces to isolate resources and cgroup to give resource allocation. So for example, if I want to say this program is going to get 1 GB of RAM, or this program is going to run on one CPU or first CPU, correct? All of this thing is being done with the help of cgroup. And Docker, which was the runtime which is very popular, relied on these features to create containers. So again, remember, the containerization is a feature of the underlying OS. What Docker or any other tool does, it basically uses those features to create containers. Hope it makes sense. So like Docker, I can have some other way of creating the containers as well. Okay. So that's what happened. So when Docker was kind of becoming very prominent, people thought we should do the containers in a very generic way rather than focus on only Docker way. So the companies came together or the community came together and they built a standard called OCI. And with this standard, they created a way or kind of decided a way to create containers. So we made a standard and runc is the basic implementation of it. So I can use the runc tool as a generic tool and to create containers. So let me repeat again. So rather than going by just one way, community says that let's create a standard, which we call it as an OCI. Now, once we have a standard, people can make the software in a different ways to use it. Like think about a standard to whatever, like for power, right? Once we have a power connector as a standard, right? I can put any device and make it run, correct? Similarly, here OCI is a standard, and then we can create these runtimes in different ways. So runc is the basic runtime which we can use. So now, similar to Docker, I can have other runtimes which can use the underlying feature of the OS to create containers in a standard way. So Docker, runc, containerd, podman, whatever you hear those terms, right? They are nothing but a way to connect with the underlying OS to create containers. Hope it is very clear to everyone now that um, what are the features of the underlying OS which can help us create containers, right? So now I'll just quickly go over a few more things. This is fine. So if I talk about Docker now with Docker, if I look at the Docker's architecture here, this is how the Docker architecture looks like. So as you can see here at the bottom of it, we have the runc. So runc, what was there earlier, it is a very basic minimal tool to create containers. So Docker engine or Docker daemon, what we have, it uses something called as containerd. And why is that? So runc is very minimal and it cannot manage multiple containers as a group. So runc was built to just create single container. Containerd is a way to kind of manage these containers in an efficient way, and then Docker is using it. So containerd is the runtime which is using the runc. You can think of as a low level runtime to create containers. So this is how the hierarchy looks like. We have a Docker engine which talk to the containerd and which will talk to the runc to create containers. Correct? So hope it makes sense. I know this kind of went a bit too fast, but let me kind of just summarize a bit more that. So we understood there is a standard way to create containers. Runc is the basic implementation of it. And then containerd is a way to manage multiple runc containers. So ideally, I can just have containerd to manage all of these containers. It's perfectly fine. And Kubernetes does that. Kubernetes uses container to create containers. But then for the Docker part, this is how Docker daemon looks like. Okay. So with this basic understanding, whatever we have understood so far, let me know if any questions are there. Now I'm just going to install the Docker package now to create the containers. So I'm just going to run the command here, apt install docker.io. This is going to help me create the containers. So Docker, first I'm installing a Docker daemon. So Docker daemon is going to, so once Docker package is going to get installed, you can see here, the containerd software has just come here, right? Containerd is getting installed as a part of Docker installation here, okay? So now my Docker is getting installed completely. And if I do Docker version, what you see here, you see two things here. One is a client. So this Docker library or Docker CLI, what you see, it's a client program. And this client communicates to something called as Docker server. So when you're installing this, I'll just run this command systemctl status Docker. You can see here there is a Docker service running, which is running a Docker daemon program. So when we install Docker on a system, it is creating or it is kind of getting both client and server running on the same machine. But what can also happen is my Docker clients, in this case, my Docker client and server both are on the same machine, but I can have my client to communicate to a different Docker daemon as well. So Docker CLI can connect to a Docker daemon running locally, or I can connect it to a different machine as well, which as long as I have a connectivity there. Okay. Now this is how the basic architecture of Docker looks like. So what you see here is we have this client program, which I told you. This is a Docker CLI, which I have. Sorry. So here is the Docker CLI which I have. Now this Docker CLI, when I run a command, it's going to connect to a Docker daemon, which by default runs on the same server what I have or same machine what I have. So if I do a Docker, let's say image ls, so this client is communicating to a Docker daemon running on the same machine, and this client is saying that, let's say, create a container for me. Okay. Now, if I have the image, so I told you about image earlier. Image is nothing but the kind of say the packaged software and dependency. So, for example, if you have your Python program or C program, you will have the binary and the respective the shared library for it, right? So that those have to be part of that particular image. So if I have an image, I can create containers from it. So for example, if I'm having the Ubuntu image, I can create a Ubuntu container from it. But let's say if I don't have an image, I have to get that image from somewhere. And that is something nothing but registry. So registry is software which is like a GitHub of images, where you have all the images and then you pull those images locally and then create containers. Okay. So let me do that. So I'm going to create a container now. See here. So Docker, I'm going to use a command called Docker container run. So this is the command to create containers. And I want to create the container in the interactive mode for now. So I'm going to use the -i for interactivity and -t for terminal. So I'm going to give these two options. I'm going to give a name to it. Let's say I'll give a name to it as my Alpine, something like that. Whatever name I want to give. And then I'm going to choose the Alpine image. Alpine is a very minimal Linux image which I can use. So I'll say Alpine and say sh is the command which I want to run once the container starts. So if I start my container, I have to tell which command to run. So I'm going to say sh command here. So now what you can see here is it is saying that unable to find the image locally. So what happened here? I'm not able to find the Alpine image locally. So I'm going to go to the registry here. This registry by default is Docker Hub. So if I go to hub.docker.com, you can see here under this Docker Hub, I'm going to find different images. Alpine is the first one, as you can see here. I can search for Nginx or MySQL or whatever. So by default, I go to a registry and pull the image from there. Correct? So now what happened is I went to the registry from my terminal and I pulled the image. So once the image I have got locally here, and if I do, let's say now, Docker image ls, you can see I have the image available with me. And from this image, I create container and I am now inside the container here. So I'm in the terminal, as you can see here. Correct? I can now write any commands. I can maybe create a file. So I'll run the date command here and dump the output into a file. Correct? So my content is in my file 1 here. Hope this makes sense. So I got an image from a Docker Hub, pulled it, and I did a container creation from it, and now I'm inside it. Okay. So this is how I can create a container on my system. Now this container is running in the foreground, which means it is kind of blocked my terminal right now. As you can see, I cannot kind of, this is not my host system, right? So let's say if I want to detach myself from here, I want to keep this container running. So currently, if I look at Docker container ls, as you can see here, it is in the running state here. So I did talk about this thing, but there's a container called myalpine running. It is in the running state. Okay, let me type exit here. And what's going to happen? This container would now go in the stopped state. So now if I do Docker container ls, you'll see that it would not list this container in the running state. It is in the stopped state. And if I do Docker container ls -8, it is in the stopped state now, which we can see here, exited. Correct? Similarly, now let's see if I run the container with the command of Docker container run. And now this time I'll give -d option to run the container background mode. In the previous case with the -i -t, it ran in the foreground mode. But with -d, it would run in the background. Okay, so let me give a name to it. Now let's say web name. And now I'm going to use the container of Nginx, but with the version of Alpine. So if you recall in the previous case, I'm not sure whether I can show the output to you or not. It is not available. But what happened is when we pulled the image of Alpine, by default, it gave me Alpine and the latest version. So if I go to my Docker Hub, click on any one of the image which I have here. In this image, I can see different versions here, like 8.033 and so on. But one of this is also going to have the latest tag as well. A tag is nothing but a version, right? So by default, it gives me the latest version if you don't give a version to download. But in my current case, I'm saying download the Alpine version. So here, and this is software, Alpine is a version. So what's going to happen now? It is going to download the version of Alpine for the software of Nginx and give a name for web. So again, as you can see here, it is downloading the Alpine version of Nginx. It is now going to pull the image and now it creates a container, correct? And if I do, and you can see now it has come out of my terminal or that what I had there, right? It is now it has given me back the host terminal back to me. And if I do Docker container ls, you can see here it is saying that there's a container called web running here with the web name. And as you can see here in this case, I have this big ID, long ID here, right? This is the container ID for me. But when I list the containers, it is going to give me only partial ID here. So it's the complete ID, but this gives me partial ID here. So I can refer a container via the full ID, via the partial ID, or via the name. Correct? This is how I can give my container or refer my container. Make sense? Now, there's a command called inspect with the containers, from which I can find more information about the container. Okay. So if I do Docker container inspect the web container, right? So I'm referring the web container here. So now you can see here for this web container, I'm going to find out first of all the PID. So what I mentioned earlier is every container is equivalent to a program running on the host system. So as you can see here, when I did an inspect of my web container, which I ran the command earlier, so I did a command of give me more information about a container called web, which is a container name for us, right? And you can see here it gave me this PID. And this PID is nothing but the actual program running on the host system. So I told you earlier, a container is nothing but a program running on the host system with a its own kind of a jailed environment, the host name and IP address and so on there. So as you can see here, I am running this container which is with the name of web, but at the same time the respective program is running on the host system. So a container is equivalent to a program running on the host system with the respective constraint of getting its own host name, IP address, and so on. Hope it makes sense to all of you. And now, because it's a program, right? The way I was assigning the resources for my uh, programs, I can do the similar way for the container as well, because container is nothing but a program for me. So if I could allocate 1 GB of RAM to a program earlier, I can do now so as well with containers. So if I run the Docker containers, Docker container, run command and put --help here, it's going to give me all the help option. And now you can, if I look at here, let's say memory. So you can see here, I can configure the memory limits here like that. The question was on the chat, resources. So when I'm going to create containers, I can put my resources like this, how much CPU memory I want to give. So hope this makes sense to all of you, that this is how I can allocate resource for my containers. Okay. So we don't have much time. I'll still kind of talk about a few more things and then we'll move to the orchestration there. So we understood how we can create containers on a single machine. That is very much clear. I'll just talk about a couple of more things and then we'll go to the orchestration part here. Now, once we have the containers created, the next thing you want to do is, of course, perform different operations to it and so on. Okay, I'll just talk about the image part here, and then we'll jump into the the orchestration part here because the time limitation. So what you can do is, once we finish this particular webinar, you can go and then do the hands-on labs, whatever you want to do with the course, right? The question was there, how to run the image against the container. So no, so basically you create containers from images, from image what I have. So for example, as you can see now, I have now two images here in my system, and from this images, sorry, Docker image ls. Now from this image I can create containers, and I can create multiple of them. So for example, we just ran the web container earlier. Let me create multiple of them. So I run this web container. Let me create one more called web1, then create web2. So as you can see here, I'm having only single image, but from this I can create multiple containers, right? As you can see, there are 4 containers running from the same image now. Hope it makes sense. Now let me quickly talk about how we can create our own images, correct? So now how to create our own image. One is, whatever container we are running, from there we can create an image. So for example, let me create one container here. I'll give this container name as my Alpine 1 here. So now I am in the my Alpine 1 container here, and I'm going to create a couple of files here. I'm just going to the same date command here, file 1, file 2, and so on. So I have got 2 files here. Okay, let me ask you one question before I move on. Let's see if I create one more container here with the name of my Alpine 2. So as you can see, under the my Alpine container, I have these 2 files here, which are file F1 or file 1 and file 2, correct? Now, my question to you is, I have used the same image to create one more container. Now, do you expect those file 1 and file 2 to come here as well? Yes or no? No, right? Because it's a different container altogether. Correct? That's correct. Now, what we have to do is what we can do now is, so let's me kind of go and talk about that term here quickly. Yeah, so what happened, this is how it looks now, that we have our base image. From this base image, we have multiple containers created. Now these containers have their own temporary storage to work on. So my Alpine 1 and my Alpine 2 had their different temporary storage to work with. Okay. Now what's going to happen is, of course, the content of this is going to be different. Correct. Now this temporary storage exists as long as container is there on the system. If I remove the container, the data is gone as well, which means you should not put any persistent data inside your container. Make sense? But what if I want to make a new image out of the running container? So think about, you have a team, right? You have a team of 10 people. Now what you want to do is, you want to give everybody a custom image which they can use. So think about, you have taken a Ubuntu container. In that Ubuntu container, you have installed 10 packages, compiled the source code, whatever it is, and make your own container ready, which is good for your work, because everybody's work is going to be different, right? Now you have made that particular container working for you. Now, if you lose the container, everything is gone. So what you want is, whatever change you have done, you want to persist that into a hard disk or with a given new image name, which you can reuse and give it to your teammates as well, so that you can save their time. That is called as a commit process. So what I can do is, whatever changes I have done, I can save it into a new image, and then I can give it to my teammates. So let me show you that particular part here. So now, as you can see here, I am in the my Alpine container, my Alpine 1, and here I have these 2 files. Now we discussed earlier, if I type exit, it would bring me out. But if I type Control P and Control Q, it would not stop the container, just detach myself. So if I see that, it is now my container running state anyway. So I have got this my Alpine 1 container, which has these two files. So what I want to do now is, whatever the change I have in this temporary layer, I want to make a new image of it. So I run a command called Docker container commit. Commit what? Again, I can find the help to find out information about it. But for now, I'm just going to give my container name here, which is my Alpine 1. And I want to create an image, which is, let's say, my image. So what happened now is, it has created a new image for me, Docker image ls. So you can see here, I have got this new image for my container. And if I create a container from this my image, I would get those two files here. Sorry, sh. You can see here in the new container, I have these two files. Correct? This is how we create the image, and this image currently available locally only on my system, which is actually getting stored in the Docker document root, or you can say Docker root, which is under where lib Docker somewhere. It would be stored. Okay. This is where the image is there. Now I can give this image to Docker Hub to save it there and so on. So I'll not go in that particular thing right now, but you understood that how we can create our own image. That is what we have done manually. But if I want to automate it, that is how we do with the help of Docker files. So if I'll talk about Docker files, which I'll not talk about right now, but with Docker files, I can automate the creation of it. Okay, so I can do that. Then similarly, I can manage the networking for my container. So if I look at now this web container which I have, Docker container ls, this is container of web 1 or whatever I have. All of these containers gets a what we call, say, the private IP. So if I do a Docker container inspect, let's say web 1, it is going to find its own private IP. As you can see, the private IP is being given here. And if I access private IP, you can see I can access the web page here. So what I'm telling you, every container gets a private IP. That is because of the Docker bridge, which I think you can go and check it out later. But when I get a container, get a private IP which I can access with the container. But if I want to expose it publicly, I need to do port mapping. So what we are saying here, let's say if this is my host. In this host, I have a container running here, and this container running on port 80, for example, in this case now. Now this is a private IP which is having. But if I want to expose it publicly, what I can do is I can do a port mapping. So what I'm trying to convey here, on my host, whichever my host system is there, if I open up a port here, for example, if I say I'm going to access on port 8080 here, or port whatever it is, so I'm going to do a port mapping. So if I hit my host system on port 8080, it is going to route the traffic to the container on the private IP here. So that way I can expose my apps publicly. So let me show you an example of that. So in our current scenario, what I'll do right now is to show the demo. Yeah, so I'm going to create one more container here, and this time I'm going to use, let's say, give a name of 6, and I'll use this -p here. So I'm saying map port 80 of the host as well with the port 80 of the container. So first with the -p is the IP, so I can say maybe 9000 here. So I'm saying map port 9000 of the host with the port 80 of the container, but I'll say port 80 for now here for some reason. So I'm saying map port 80 of the host with the port 80 of the container. So once I do this, what's going to happen is, if I'm going to hit my host IP, right? So I have a host IP here, which is this one here. And if I access this on the port 80, I'm going to get the content of my container. So for example, that is what I can see in this app sample here. So what you see on this particular page, there is a lab URL. And if I click on it, this is actually accessing my host port 80 here, and I can access my web page publicly. Correct? So I have deployed a container and mapped it to the public IP at the host system as well. This is how the applications running in the host system are publicly available. Okay. Then we can also manage the host, the storage, because we discussed earlier, if you remove the container, the data is gone along with it. But then we have this storage management. So what I can do is I can assign volumes to my containers. And with those volumes, the content of the volume would stay on the host system or somewhere on the internet, wherever depending on the volume what you have. So if your container dies, data stays in the volume. I think we can explore it later. And the last part here is Docker Compose. With Docker Compose, for example, if you're deploying a multi-container app like backend, front end, if you want to automate the process, we can use Docker Compose to do it. Correct? That is what this Docker Compose tool is, which is going to help you deploy these things as a single unit. So you say backend, front end, and then you run the command, and everything comes together. Okay. So I know it's kind of a bit fast, but I think you have got the idea about containers. Yes or no, guys? Are you able to understand what the basics of containers? Yes or no on the chat, please. Okay, Dhananjay says yes. Okay, great. Good to have all the yes here. Okay, nice. Let's now talk about orchestration here. So what is orchestration here? So what we just saw right now is we are deploying the containers on a single host. Of course, I have deployed multiple of containers here. That is understood. But then if this host goes down, all the containers go with it, correct? So for example, if I do power off this command, all the containers what I have. So for example, this app which is running here, correct? If I do a power of the machine, as I do it the power off, would this thing available? No, right? It is gone. Because if my host is down, then nothing is going to happen. So that is why you cannot use the Docker or a tool like Podman, whatever, which is running on a single host. It is not going to work out. Clear? That you are not able to, you're not going to kind of have this kind of setup for production. So what we need in the production is we want some kind of high availability, and I want fault tolerance, I want scalability, and so on. And that is what something called as orchestration is going to give you. Correct? So at a very simple level, you are going to kind of create a cluster by combining multiple nodes together. And when you run those containers at scale, right, on those machines, that becomes orchestration. Correct? So again, as I discussed earlier, on the courses section, you have the Kubernetes 101 course, which is free, which you can use. And once you log in there, you can find out one video which talks about what are the orchestration in detail. So you can watch this video to understand what orchestration in detail. But as we are here, I'll just talk about few features, which also you can explain in the video as well. Okay. So we discussed already that about containers, why we need them and all that stuff. So this is all fine. But these are the main features why I need an orchestrator, like Kubernetes and many more. There are many more options are available for you. The first of all is container provisioning. So what is going to happen in the orchestration layer, right? I'm going to combine or I'm going to create a cluster by combining multiple nodes. So for example, if I have one node, second node, third node, and fourth node, whatever number of nodes I have, what I do is I combine all of these nodes together and form a cluster. And now I'm going to deploy my applications on these nodes. And that is the way I'm going to make it highly available. So what happens when I create this cluster? Like in this case, I have 4 nodes. I can say one of my node is a control plane and remaining are the worker machines. Okay. So I'm saying that I have a cluster with 4 machines. One of it is called control plane or a master node, you can say. Remaining are the worker machines. So the first feature I'm going to get the orchestration is container provisioning. What does it mean? Now, I'm not going to go to individual nodes separately and create containers there. No, I'm not going to go to individual machine and create containers separately. What I'll do is I'm just going to request to my control plane, say that go and deploy these apps for me. And control plane would go and manage and deploy my containers on different machines. That is what we have is the container provisioning. Hope it makes sense. The second feature what we get is a fault tolerance. Now the same thing, right? The way we run the power off command on the one node, what would happen is whatever apps are running, for example, if I shut down this machine, whatever apps are running on this machine, it would move to other instances or other nodes there. So I'm going to get, first of all, the node level tolerance. So if a node dies, automatically apps of that machine goes somewhere else. That's one part. Similarly, I'll have an app tolerance as well. So for example, if something happens to the app, now when something happened to the app, my controller would know that something wrong in the app. Let me restart the app again, or let me create another copy of it. So we are going to get the fault tolerance at the app and the node level. Then the scaling thing. So like again, if you look at what is scaling, I want to create multiple copies of my app based on the traffic or based on the requirements. So for example, think about during the day, you have a lot of traffic, but in the night, the traffic comes down. But if you run the same infra throughout the day and the night, right, you would pay additional cost. Think about similarly in Flipkart, right? If they're doing this big billion day sale, right? In those big billion day sales, they're going to have a lot of requests coming in, correct? Only for that week, correct? But remaining time, they have less traffic comparatively, correct? So now I need a way to scale up and scale down based on my requirement. So again, that is the feature I'll get with the orchestration. So again, there can be a scaling of applications, and similarly, we would need scaling of nodes as well, because at some point of time, whatever nodes I have, they'll finish, right? So I would need a scaling at the node level as well, correct? Then I'll get a feature of service discovery, correct? What does that mean? So think about when you open a website, right? Now this website you open by giving a domain name like cloudware.guru. You just gave a name and the site get opened. But behind the scene, I may be running the applications by or that cloudware.guru website is served by different VMs or containers behind the scene. But for the end user, is just a single URL or the name here. Same thing would happen in Kubernetes. You would have multiple replica of the app running, correct? But you refer it by a single name. So that feature has to also come within the environment, within the organization as well. That is service discovery, what is there for you. Then you need deployment strategy. So for example, when I'm moving my app from the version V1 to V2, so think about you have deployed one version of the app and you have deployed 100 copies of it. So you have a cluster of 20 nodes, for example, and you are running 100 copies of your application because you have that much of scale. Now you move the app from V1 to V2. Now what will happen? How you are going to what do you call say upgrade the applications from V1 to V2, correct? So you have 100 applications running of the same app, right? 100 copies running of the same app, and the customer traffic is coming continuously, correct? Now if you say that to upgrade I'll take a downtime, so if you take a downtime, what's going to happen? A customer is going to suffer, right? So what I need is I want a strategy using which I'll not take a downtime but still upgrade my app to the newer version, correct? That is strategies I have to apply. That is again, there are studies of different type which we will look at maybe sometime in future. Then we need something called orchestration of storage as well. Now when you deploy your applications running on different machines, and because of fault tolerance, right, what can happen is one container moved from one machine to another machine. So whatever storage it was using, it has to move along with it, correct? So all of these features are going to give us by the orchestration. Hope it makes sense. And there are different softwares are available which are going to help us achieve or kind of help us get these features like Docker Swarm, Kubernetes, Amazon ECS, HashiCorp Nomad. All of these things give these kind of features. But at this point of time, Kubernetes has kind of won the war to give you the all the features which I talked about and much more. So the two features of Kubernetes kind of make it very much prominent. One is the kind of a say the Kubernetes architecture itself. Like for example, there's a cost of pod in Kubernetes. That pod concept kind of try to mitigate a lot of problems which you would have only single container based things. So I'll not go into much of detail in that right now. Then we can extend Kubernetes to our own requirement. That's another feature of Kubernetes which is making it very popular. Correct. So again, I have given you very basic thing about Kubernetes right now. I again said that there's a few free course which you can go and try it out. Correct. Because we are not having enough time right now. So, but again, for all of these videos which I talked about already, for all of this, for the entire course, right, you already have pre-recorded videos and the slides there, and you also have a live environment for 40 hours, which is sufficient for you to kind of do all of these things, right? So you can go ahead and practice all the basic level of Kubernetes, and we would also be publishing the Kubernetes basic course, complete recording on the YouTube as well, so that also you can use. Okay. Um, so I hope I know we already kind of few minutes away, but I hope this particular session was useful for you guys. Let me just put a poll for that right now. What do you think that this particular content what I delivered is worth of your time? Okay, thank you guys for your time today.